Hey, Sean's here, and this will be the solution for the first task in this lab. And again, this lab is not prepared by me at all. This is by the boy Aggressive Hiker. Go ahead and give this entire repository a nice star on GitHub. Show your appreciation, because this really is an excellent lab. So to get started, we're going to go ahead and access our setup for this lab. And again, if you haven't set this up, you'll want to watch my guide on getting it set up, or just follow the nice instructions here to get it set up. But we're going to go ahead and get this started up. This is a very nice task. I have heard that this is actually one of the things they do make you do. They probably have changed it by now as far as what you actually have to do. So I wouldn't 100% count on having to do this, but this is basically like one of the first tasks you're told to do. So essentially this asks you to kind of restore this second server, because it's, if you notice, we've already fully booted, but we have no login prompt to actually access the server's environment and do things that we normally would like to do on the system. And this is a very realistic scenario. God forbid a front-end dev ever had admin access to the actual production web server, and he's fiddling around on there and kind of doing stuff. And front-end devs are smart, but they're not really tech savvy, and very likely they kind of trying to help, they do something that they don't really know exactly what the full consequences of it is, and they kind of wipe out the entire environment. And that's where a sysadmin comes in and kind of fixes everything for them, because obviously a web dev doesn't really know what to do if it's not in a JS framework like React or something like that. Now, what you'll want to do, of course, close this down, get it started back up, and we're going to hit F12 to go directly into the pre-boot environment. Make sure you hit that. Then we're going to choose, obviously, the first hard disk, because we really only have one, or you should only have one, based on the previous lab setup. Okay, so now we're in the Grub environment, and for those of you who don't know, this is Grub version 2.06, and what Grub is what's called a bootloader. Now, a bootloader is a program that's located in the first block of memory, the first 512 bytes. This is often referred to as the boot sector, and what a bootloader does, if you can figure out from the name, is it basically starts the tasks that help get the operating system up and running. And the main task of the bootloader, and there is other things in the boot sector, but the main task of the bootloader is essentially to load into memory the location of the next part of the bootloader, because in the first 512 bytes, it's not the complete bootloader program. It's only part of it, just enough to load into memory, like I said, the location of the next part of the bootloader. And the next part of the bootloader is responsible for running some tasks and getting those tasks done to, again, get the kernel up and running, get the operating system up and running. And one of those tasks is to transition control after it's finished its task control to the kernel, and when it transitions control to the kernel, it's going to also pass some parameters over to the kernel to tell it, more of what to do, give it the full instructions on what to do to actually get the operating system up and running. So that's what we're actually editing here from the Grub edit line. We're going to append onto that Linux line there, about 1, 2, 3, 4, the fourth line, that entire section there, that's actually the boot parameters. And now we're going to append onto that something called rd.break. And to understand that, we also have to explain that for Linux, when Linux is first loaded and it gets started up after the bootloader passes off control, what Linux does is mounts a temporary file system called init_ram_fs. Init for initiate, RAM for random access memory, which is also referred to as main memory, file system. So this is, again, an intermediate file system that is used to help the kernel run some tasks. It provides the kernel the tasks and drivers necessary to actually get the operating system up and running. Now, when the init_ram_fs has finished all its tasks, when the kernel no longer needs it, init_ram_fs will, of course, dismount itself, or the kernel will dismount init_ram_fs, and then from that point, the control of the kernel will get passed over to, or rather not control the kernel, but control the operating system is going to get passed over to the actual root file system. That'll get mounted onto the kernel, and the kernel will be able to actually load the operating system, get it up and running. Now, we, of course, don't want to actually reach the operating system because the operating system is not functioning as expected, and we want to edit some configurations in that root file system. That way we can actually control it and get it working the way we want to do. So that's what the purpose of the rd.break is for, because it's going to break after the init_ram_fs finishes all of its tasks. It's going to break right after that so that we don't actually transition and mount the root file system. So with that being said, we're going to go ahead and actually modify the boot parameters now. So this, again, this whole entire line, starting with Linux $root, that's all one line. That's the entirety of the boot parameters. So we want to get to the after the swap part. So we're just going to go down here And this is basically where we want to add our little rd.break statement. So again, just put rd.break. Now that that's there, that's really all we have to do. So we'll go ahead and hit Control X to exit that and force the boot. And again, this will break before we ever get to the spot that I told you about, actually loading to the file system. And there we have an actual TTY, teletypewriter, or otherwise known as a little shell that we can actually start entering commands in. So this is known as the emergency shell, as you can see right here, entering emergency mode, exit the shell to continue. We obviously don't want to exit the shell because this is what is going to allow us to do what we want to do. So the first thing we want to do here is we actually want to mount the file system, because if we mount the file system, we'll actually be able to start doing things in it and obviously do the configs that are necessary. We'll go ahead and enter here, and the command you want to enter, you don't have to enter sudo, so I don't even know why I began to do that, but it was just kind of a reflex. We'll do mount -o. We're going to remount with read and write permissions, because otherwise we would be mounting it with just read permissions. Obviously, we need to do some editing to the configs, so we need those write permissions. So we're going to do it like that, and that's the actual root file system. But just to save us some time and add a little bit of extra security, protect ourselves from doing anything that might blow back on us, we're going to enter what's called the Chroot environment. And essentially what this does is kind of make the shell interpret anything else further as if the root directory from which the shell is operating within is the sysroot directory. Now, we could do what we need to do as far as editing all the configs without doing this. But again, this will essentially make the shell essentially see every action that we're doing as operating with the sysroot being the root directory. And obviously, you can't go past the root directory, as in the root directory is the fully mounted file system. I'm probably doing a poor job explaining this, but essentially, you can't go anything up. You can't go up and further past the root directory because it's the root. That's essentially the top, and you can't really break that barrier. So what this does is any processes that might try and edit something past that root directory, they won't be able to, because the shell can't interpret anything above that, because again, it sees the sysroot directory as the root directory. So that's essentially what this does. This is called basically Chroot Jail from the research and documentation I've seen. So again, we're going to go ahead and chroot into the sysroot. So now we're essentially in the actual file system, or rather the operating system. This is basically, for all intents and purposes, right now, the shell basically believes we're in the file system when the operating system is up and running. Essentially, that's what you can treat right now, what's happening as the current reality. So now, if you remember, the previous edit we had done to kind of break this server is that we set the boot target to network dock target, if I remember correctly, through system control, set default network target. So all we have to do now is essentially set it to the target that will allow us to interact once more with the TTY using the shell or a text, command line interface. And all you have to do for that is system control set default multi-user.target. And it'll say this here, but we've pretty much done what we need to do at this point. So at this point, you could boot or rather reboot, and you'd be totally fine. But we did also, as part of the configuration for doing this, change the password to something that was like random and that we wouldn't be privy to remembering. This also might be something that could happen as a result of, again, some web dev kind of doing something beyond his capabilities. Go ahead and clean the screen here. So the command to do that is simply password. I'll ask you to change the password for user root rather. So we'll choose something nice and simple to remember. And then we'll type it again. It failed the dictionary check because, again, I made it something nice and simple to remember. Obviously, in the production environment, you would not set it something too simple to remember, but I'm just doing this for ease of use, rather. So we'll go ahead and do that. And now, actually, one more thing. So because in a Red Hat Enterprise Linux environment, you'll likely have SE Linux enabled. Of course, with SE Linux, there's a lot more granular security controls in place, including the labeling system, which is the primary manner rather in which SE Linux operates. So we'll just go ahead and have to add this to the root directory. This will be an relabel rather, and that'll just make it so that basically all the changes that we've done here will not cause any unwanted denials and kind of prevent us from interacting with stuff again, just due to, again, all the different configurations we've done. So it's good to do this here. Go ahead and clear that, and we're good. So we can hit exit and then reboot. You'll see it fully reboot here. Then we just hit enter. And the previous parameters that we passed to the kernel in that previous boot, those are gone. Those are only temporary, just for that one session. So now we're good. And this is why, of course, you never let web devs touch production servers. And you'll see here we have the full prompt, and we're back into the system. And we can, go ahead and enter commands as we want, and everything is back to normal. So that's the solution for the first task, how you get it done. Hope this helped. Hope I explained everything that was going on clearly so you actually understand what's happening, because it is important to understand the grub environment and rescue mode, recovery mode, what's actually happening when you edit boot parameters like that. I think that obviously I could have just shown you the solution how to do it, and you would have been able to, of course, if you ever had to do it, but I don't think it would have sunk in if I didn't kind of explain every step of the way. So I hope that wasn't too boring, but if this was helpful, great, and we'll be moving on to the next solution from here. Thanks.